The final video that I'm going to produce for lesson 4.4 is how to use sinusoidal function to solve problems. The problem that we're going to look at is using the sine or cosine model to, or sine or cosine function to model the average temperatures of Seattle, Washington. So they give us a temperature of Seattle, Washington from January to December. Our first order of business is to get these values into our calculator, and you put them in your stat and you edit your list and you put in 1 for January, as I suggest, all the way to 12 for December, and all the corresponding temperatures for those 12 months. Second thing we want to do is we want to make sure we set up reasonable windows. So our dates, our months on our x-axis, I went from 0 to 14 to make sure I had room for the 1 through 12. I also made sure I went low enough for the temperatures. I went down to 35 degrees and all the way up to 70 degrees to accommodate all the temperature ranges by a scale of 5. And then I also made sure that I had the scatter plot set up correctly in plot 1. I have a scatter plot, list 1, list 2. It should be good to see what this temperature cycle looks like. Okay, so what we're seeing on our calculator should be the semblance or resemblance of a trig function, either sine or cosine. Now we have our option to pick either one. But as with all temperatures, we would expect them to cycle through similar temperature values from one year to the next. So they're cyclical in that respect. So our job is to find the equation that models this and then to be able to take that model, put it in, and then be able to predict monthly temperatures after that. So the first thing we're going to do is we're going to try to find where is the center of this data. So we have our maximum point up here. We have our lowest point down here. We want to find the average of those two. So it's not allowing me to do that, but I want to find the average of those, and to simply find the average of the highest temperature, we'd take 66 plus our lowest temperature, 41, and find the middle. So what I'm working on is finding the center line. So 66 plus 41, that's 107, and 107 divided by 2, that should be 53.5 degrees. So now what I know from my equation is that the center line has to be located at 53.5. So okay, so what I've just figured out is the value of D, because that is the one that controls the center line, or I guess they call it the midline of our graph. Once I know the midline, I can then figure out how far above and below the midline I'm going. So now I'm working on the amplitude. So if I know the center line is at 53.5 and I have to go up to 66 degrees, so I'm going to take 66 minus 53.5, and I'm going to figure out what the amplitude is going to be with that calculation. So I'm going to use a little technology to help me with that. I'm going to take 66 minus 53.5, enter. That means our amplitude has to be 12.5. So now I know the value of A, I know the value of D. Now the next part I'm going to work on is looking at the period length. And we can look on our graph to figure out where is the highest point of our graph, where is the lowest point of our graph. I guess we've already talked about that, but between the maximum and minimum, we should have half of the period of any sine or cosine function. So I'm going to give you some more room, and hope I'm not making you busy by flashing back and forth to all these screens. But this is where our lowest temperature was. That was the first month of January. This is where our highest temperature was. That was the 8th month of January. So that is a cycle between the lowest point and the highest point, which should be half of the cycle of our trig function. So especially since I'm gonna elect to use a cosine function on this one. So here's what I'm going to do to calculate the period. The period is going to be equal to twice of the maximum minus the minimum point. That's the best way that we can approximate one full period. So it's going to be 2 times the maximum occurred at month number 8, the minimum occurred at month number 1. So that means our period is 2 times 7, or we got 14. So we have 2 times 7 times 14. Now in order to get our period, this is the value of, what I'm looking at here is the value of B that I need to place in our formula. So in order to find the value of B, I had that right the first time. This is all about the period length. It took that long to get through one full cycle of values. But we have our period is equal to 2 pi over B, and really what we need to find is the A, B, C, D. So I'm trying to find B. I know the period is 14, So 2 pi divided by some value of b will help us determine this coefficient b that controls the period. So I'm going to multiply both sides times b, and then I've got to take both sides and divide by 14. So now I got 2 pi divided by 14, which means b, the value that's controlling the length of that period, is going to be pi sevenths if we reduce. So now I know the value of b is pi sevenths. We got a and d calculated. So the final thing that we need is the phase shift. So now what we're going to do is recalculate the value of that phase shift. In order to get the phase shift, I'm going to use this concept here. The phase shift, PS, is going to equal, and this was kind of the form that they had given us to work with before, and I'm going to bring it back out, the opposite of C divided by B, and B was the absolute value of B. So I'm going to place that in and find the phase shift. Now the phase shift in this thing, we already know how far our cosine curve has been shifted. I'm going to go back to the graph here for a minute. Typically, the maximum point in any cosine graph should be happening at the origin or at time 0. In this case, we'd want it to be our first data, which is on January 1st. So this point here needs to be slid over here. Well, that is 8 units away. So I know the phase shift has been slid 8 units to the right. So that's what I'm going to put in for the phase shift in this formula. So in our formula, the phase shift that we had was 8 units to the right of 0, and our cosine should have a maximum at 0, so I've got to push it over 8 units, equals a negative c, and c is the value that we're trying to get here, because c controls that phase shift, when we already know the value of b, and that was pi sevenths, and the absolute value of pi sevenths is pi sevenths. So I want to get rid of dividing by pi sevenths, so we're going to multiply times pi sevenths, both sides, times pi sevenths, and times pi sevenths. I'm going to back up. This seems a little sloppy, so let me try this. Instead of dividing by, we're really multiplying by 7 over pi. So in order to get rid of multiplying by 7 over pi, I got to actually multiply times pi over 7. So I think we're okay before pi over 7. Just want to double check and make sure I use solid math on that and I didn't make a mistake. So what we're getting is 8 pi over 7 equals a negative c, or c is equal to a negative 8 pi sevenths. Now I've got all the parameters in place, and I should be able to replace all these values in our cosine curve. So try to see if I can get all those values in one screen. So I've got y equals a times the cosine of, I'm going back to their form of bx plus c plus b. Substitute in all the values that we know. We had already calculated that the amplitude was, I think that was 12.5. Yeah. So I'm going to go 12.5 as a decimal times the cosine of b, and the value of b was pi sevenths. So I'm going to put pi sevenths in for b, x. Then the value of c was a negative 8 pi sevenths, parentheses. Then our center line was situated at, I believe it was 53.5. So 53.5. Now this is the equation I think should model that data fairly well, and I'm going to put that in the calculator and see how well it fits. So see if I can get that all over here, and we'll clean up that screen, and we'll try to plug it into the y equals. So we've got 12.5 cosine of, and I got to go parentheses, pi sevenths x, so second. And where's my pi key? I can't see it. Pi, I think that's it. 7, so divided by 7. X, so times x. I think I'm going to put that x in with the pi, so I'm going to go second, insert, x. So that's pi times x divided by 7, which is pi sevenths x. Then minus. So I have a minus key. Then I want 8 pi sevenths. I'm just thinking I got to be a little bit more careful with how I'm entering those, because I want the x and pi divided by 7. So I'm going to insert a set of parentheses around those. which I didn't get, the second insert, parenthesis, x times pi, so I'll just hit the times key to get that out of the way. I want to delete that symbol, so we got x times pi. I want to close that parenthesis, second insert, parenthesis, divided by 7, minus, now I want 8 pi, so I'm going to put 8 second pi in parentheses. And I wanted that divided by 7, parenthesis. Now that finished all of that cosine, so parenthesis. I think I have the right number of closing parentheses in there. It's kind of long. 1, 2, 3. Got 1, 2, 3, 4. I think I've got them. Kind of lost track. There's quite a bit going on there. So then plus 53.5. Enter. Then I'm going to graph and see how closely that models. Okay. I got a straight line going across there. I know that's incorrect, so I bet I've got it in degree mode rather than radian mode. So anytime that happens, try not to panic too much. Got a little panic going on here. But we're going to go into our mode. Yep, I got to make sure it's in radians because that's what I measured the angle in. And let's see if that graph's any better. Okay, now that's much better fitting curve to what we wanted. It's fitting our points fairly well. It's a little bit off on the right hand side, but all in all it's not a bad fit. It fits our data really well because we set it up to fit really well from January 1 to August 1. And this is where we fall off a little bit because it's not quite symmetrical. You can see that in the scatter plot that we had. There was a symmetrical pattern. The final thing that we were asked to do in this problem, if I buzz up here, according to your model, what is Seattle's average monthly temperature in February? So if I want to find the average temperature in February, what we're going to do is we're going to use our model, and that is the second month. So I want to make sure that when I hit trace, I'm not on the scatter plot, but I'm on the model. And I want to make sure we go to the second month, and it is 42.23 degrees. So 42 degrees is a good estimate based on the model that we had. So February was approximately 42 degrees. So what I've tried to do is give you a video to see how you can use your scatter plot and how you can use your ideas of finding your midline, your amplitude, your phase shift, and your period to get in an equation that you can place into your equation to model data, and from that you can use it to predict different temperatures throughout the year. So if you have questions, please be sure to ask. Hopefully it's fairly clear. If not, let me know what things I need to shore up for you.